let's solve some problems involving logarithms. For example, this first one says ln of 10 times e to the 3x equals. So we are computing logarithm of a product. That means we have to apply the second property, the purple property, and this rewrites as ln of 10 plus ln of e to the 3x. ln of 10, we can just plug in the calculator, whatever that number is. For the second one, we see that we have a composition of two functions, ln, the natural log, and e to the 3x. These two functions are inverse functions of each other, so they cancel each other out, and we are just left with 3x. And that's the final answer. For the second property, for the second problem, we also have a product. So we will apply again the purple property, and we will have that this is logarithm of x to the 10th plus log of 10 to the x. Now, to compute log of x to the 10, we will apply this third or blue property of the logarithm, and that means we take the exponent 10 and we bring it out in front of the logarithm. So this expression is 10 log x plus, we apply the same thing to the next expression. This x comes out in front of the logarithm and it becomes x log 10. Now, log without any base here means that we are actually talking about base 10. There are two special logarithms. One is log base 10 and the other is the natural log with the base e. Natural log is the one that we saw in the first example, and it's written by ln. Log base 10 is written without any base. So in order to compute log of 10, we will use this property, and the result will be just 1. So for this problem, we have 10 log x plus x times 1. So 10 log x plus x. Okay, so let's see the next problem. The next problem is not a product, it's a division. But every division is a product in disguise, and we will use this purple property again. If you see a division, it's the same as a product, but there is a minus sign here. So I will rewrite this problem as log base 2 of 8 minus log base 2 of 4 raised to x. Now I can rewrite 8 as 2 to the 3rd power, 2 cubed minus, and I will write 4 as 2 squared raised to x. Now log base 2 and 2 raised to something are inverse function of each other, so they cancel each other out. So the result here is 3, and here we have log base 2 of 2 to the 2x, because 2 and x multiply each other, you're raising a power to another power. Now log base 2 and 2 to some power cancel each other out again because they are inverse functions of each other, and you have 3 minus 2x, and that's the final answer. For the next one, you have both a division and a multiplication, so this becomes log base 2 of 3 times 2 to the x minus log base 2 of x squared. So for the first term, log of 2, 3 times 2x, you have a product, so this becomes log base 2 of 3 plus log of 2x. For the second term, we apply the blue property, and the exponent comes out of the logarithm, and this becomes 2 times log 2x. Now we do the same for this exponent here, the only one that's left. We copy log base 2 of 3 and apply this blue thingy, the third property of the logarithm. Log base 2 minus 2 log 2 of x. And the only thing that we can simplify now is that we can say that log base 2 of 2 is actually 1. So this becomes log, oh yes, so we, if we don't know how to compute or to plug in the calculator log base 2, we'll apply this red property here, and we'll rewrite log base 2 in terms of the usual log. So this will be ln of 3 divided by ln of 2. And so in the next term, I'll just rewrite log base 2 of 2 as 1, and log base 2 of x I can rewrite as ln x divided by ln 2, or I can just leave it as log base 2 of x. Okay, for the next problem, we have a cube root. Now cube root is just another exponent. It's exponent of 1/3. So we'll apply this blue property, and we'll bring this exponent outside of the logarithm, and we'll have this is 1/3 log of x over 2. Now I can apply also the purple thing, because I have a division of x and 2, and I'll have this is 1/3 log of x minus log of 2. And that's my final answer.